When we picture the future of robotics, we usually think of one single super advanced machine, right? But what if I told you the real revolution isn't about that one perfect robot? What if it's about thousands of them all working together? We're going to dive into why the future of autonomy isn't singular, it's collective.
And that's really the headline here. The whole idea of a single, high-tech, expensive drone flying a solo mission, well, that's quickly becoming a thing of the past. There's a huge shift happening right now, moving away from the individual and totally embracing the swarm. And look, this is not science fiction. This number, 100, is how many autonomous drones the Lawrence Livermore National Laboratory is actually approved to test all at the same time. We're talking about real-world experiments with huge swarms happening as we speak.
So yeah, that brings us to our first big point. The future really is a swarm. The entire conversation in military planning has changed. It's no longer about a few big, pricey drones. Now it's all about deploying hundreds, even thousands of smaller, cheaper ones that can actually cooperate.
But what is it that makes a swarm so much more powerful than just one really complex drone? Well, it all comes down to this incredible concept called collaborative autonomy. Basically, being able to do things together that would be absolutely impossible alone. In the military, they have a term for this: force multiplication. It's a fancy way of saying that when you add a new capability, like drones working together, you don't just add to your power, you literally multiply it. Let me show you how that works. This really breaks it down perfectly. Okay, so on the left, you have a single drone. It's got one sensor, it sees one little piece of the puzzle. But look at the right. That's the swarm. Maybe one drone has a thermal camera for heat signatures, another has LiDAR to map everything in 3D, and the third is sniffing out radio signals. When they fuse all that data together, the swarm creates this incredibly rich, intelligent picture of the world that no single drone could ever hope to see. And this quote from Brian Weil at LLNL just hits the nail on the head. When you start mixing and matching different drones with different jobs, what they call a heterogeneous swarm, you're literally creating a collective intelligence that is so much greater than the sum of its parts. This also completely changes what the human operator does. You're not sitting there with a joystick flying each individual machine anymore. Nope. You're more like the conductor of an orchestra. You give these high-level commands like, hey, go survey this area, and the swarm itself figures out all the nitty-gritty details. It's just a massive leap in how things get done. Okay, so this all sounds amazing in theory, but actually making it work is incredibly hard. I mean, flying one drone? Easy. Flying 100 and making them all work together as a team? That is the single biggest hurdle that researchers are facing right now. Because the moment you start adding more drones, the complexity just explodes. Researchers like Dr. Alqudsi point out that you immediately run into communication jams, you've got to worry about constant collision avoidance, and just deciding which drone does what becomes this insanely hard problem. The number of things that can go wrong doesn't just add up, it grows exponentially. And to solve that, engineers are stuck with this classic dilemma. On one side, you have a centralized system. Think of it like one queen bee controlling everything. It's perfectly coordinated, but if that one brain goes down, the whole swarm is useless. Plus, it just doesn't scale. On the other side, you have a decentralized system, where every drone thinks for itself. That's way more robust, but it can be really inefficient. So, if neither of those extremes really works, what's the answer? Well, the real breakthrough is in cracking the coordination code, finding that perfect sweet spot between total control and total freedom. And the solution, it turns out, is a hybrid approach. It's a design that tries to get the best of both worlds, taking the strengths from each system while trying to get rid of their weaknesses. So here's how it works, and it's actually pretty brilliant. You have a central command that gives the big picture, the global oversight for the overall strategy. But then, the individual drones have local autonomy to handle the tactics. They make their own real-time decisions on how to fly, how to avoid obstacles, and how to get their specific job done to support that bigger mission. It's this perfect blend of direction and independence. And once you solve that scaling problem, the implications are just huge. As Brian Will points out here, once you can launch hundreds of these things, you've created a threat that is almost impossible to defend against. A normal air defense system just can't track and shoot down that many targets at once. But, and this is really important, this story does not end on the battlefield. The exact same tech that's being pushed for defense has unbelievable potential for civilian life. We're looking at a true dual-use technology that could change, well, just about everything. This quote really captures how this stuff works, right? The intense pressure of national security pushes innovation forward at a crazy speed, and very often those breakthroughs end up spinning off and creating some amazing benefits for the rest of us. So for defense and security, the uses are pretty clear. You can have swarms doing massive surveillance missions, sniffing out dangerous chemicals from a safe distance, or providing 24/7 security for things like power grids. But then you flip the coin and the civilian uses are just as mind-blowing. Think about swarms mapping a wildfire for firefighters in real time, delivering medical supplies right into a disaster zone, or flying over thousands of acres to check on crop health. The same exact principles of working together apply.
And all of this brings us to one final, really critical question. This tech offers so much. It's scalable, it's efficient, it's resilient. But as these swarms get smarter and more autonomous, we have to ask ourselves, where do we draw the line? How much control do we give them? Who is and who should be ultimately in control?